Dear students, now I am going to explain the properties of hydrated cement. The first property of hydrated cement is setting. Setting means once cement is added with water, it starts hardening. The process of hardening can be defined as setting. See, hardening means is the strength gain in a set cement paste. So once cement has been setted, or the strength gained by the cement can be defined as hardening. So setting is the stiffening of the cement paste or change from a plastic state to solid state. So when the cement is changing from plastic state to solid state, it is the process of setting. So there are two levels of setting: initial set and final set. So these initial setting time and the final setting time can be determined using Vickert apparatus or Vickert test, which you are going to perform in your future lab experiments. So initial set, see here, initial set, the time when a penetration of 25 mm occurs. So when the needle penetrates up to 25 mm, how much time it takes, that is the initial set. You must allow for handling and placing the concrete before stiffening. Coming to final set, when the needle does not penetrate visibly into the paste. So there is no penetration able to visible in the cement paste. So then it can be determined as the final set of cement. It is very important to ensure normal hydration. Here you can see this Vickert test apparatus. So this setting depends on the fineness of the cement, the type of cement, like fineness of the cement, the water cement ratio, consistency, the amount of water percentage adding to the cement, this is called as water cement ratio, and the use of admixtures. Admixture means any other material which we are adding to cement to gain strength or to improve the properties. Next one is soundness. Soundness means the strength or hardness, the ability to keep its volume after setting. Next one, expansion after setting caused by delayed or slow hydration. So these are the terms for soundness. Compressive strength, you are going to hear this word compressive strength so many times in civil engineering. Why? Because compressive strength means the capacity of the material or how much load it can resist. So it can be determined by stress strain relationship. So specific gravity, as we discussed about specific gravity, it is needed for mixture proportioning calculations when we are mixing different materials with cement and all. The specific gravity of Portland cement is generally considered as 3.15, and it is also used for calculating the density of the bulk cement. When you want to calculate the density of the bulk cement, then the specific gravity will be useful. So coming to water cement ratio, so this figure shows you that the x-axis is water cement ratio and y-axis is compressive strength. So this can determine you if you use 0.5 water cement ratio at this can be the value at 1 day. The value can be plotted like this at 3 days, and at 7 days you can plot the value like this. At 28 days, generally the maximum strength gained by the concrete can be determined on the 28th day. So you can read these things, what is hydration and increasing the water cement ratio, what happens, a low water cement ratio, what happens. I may be asking you to explain something. If the low water cement ratio, what are the problems you may face? If the water is increased mixing with cement, what may happens? What is hydration? So please concentrate this and prepare a few points about this, and I may ask someone to give a brief explanation about this water cement ratio. So these are the types of Portland cement. You can just go, you can read clearly, you can read and understand this. These are the normal Portland cement: moderate sulfate resistance, high airly strength, low heat of hydration. These are different types of cement. Now coming to the practical issues, students, this will be very interesting. that these are the practical things which you may see when you go to construction site, or there are several videos in the YouTube, like mixing water, how this water is mixed. So first, for the hand mixing purpose, the cement and sand is mixed like a small pond, and then the required amount of water is added, and by using this trowel you can mix this cement and sand and water. This is like cement mortar, cement paste, only with cement, sand, and you can, if you mix it with aggregate, then it can be called as concrete. So mixing concrete it is. So please read out the things, what is water mixing and disposal and reuse of concrete wash water. Let me explain this. So any potable water is suitable for making concrete. Impurities in the mixing water affect concrete set time, strength and long-term durability. Chloride ions in the mixing water can accelerate corrosion of reinforcing steel. So I'll just explain what is this disposal and reuse of concrete wash water. Concrete wash water means one you use a machines like mixture and use some cans and some material are used for concreting purpose. Once the concreting work has been done, we have to wash all the materials, all the equipments used for this concrete work. When you are washing this concrete machines used for concrete purpose, this water is having some cement particles and this water is having some impurities, so we have to take care while disposing them. So you may get this concrete wash water from the truck, from washing mixing plant, from sprayed dust control. So generally in olden days they used to leave this disposing of concrete wash water at the job site or else filling in some drainage, but currently wash water is being used as mixing water for concrete, so we can recycle it, we can reuse it. So the acceptance criteria for the used water. So after 7 days, the average compressive strength of mortar means cement plus fine aggregate, cement plus sand cube should not be more than 90% when used potable water. The set time of cement paste should be less than 1 hour, or should not be less than 1 hour, or the set time of cement paste should not be greater than 1:1.5 hours, more than the set time of paste made with potable or distilled water. What are admixtures? As I told you, the materials other than Portland cement, water and aggregates that may be added to concrete to improve the properties of the concrete or to add new properties. This is main importance of admixture. So please read this, what are the reasons for using admixtures. So I'm expecting one of the student can be able to explain what are the reasons for using admixtures. Yes. Now coming to concrete. So you are listening the word concrete from the starting of the introduction to civil engineering, and I hope you will be listening this word concrete throughout your lifetime. What is a proportioning of concrete mixtures? So what are the proportioning? The proportions of cement, water, fine and coarse aggregates, and the use of admixtures. Designers assume a certain strength and modulus of elasticity of the concrete when determining structural dimensions. The material engineer is responsible for assuring that the concrete have the properties specified by the designer. So when at the time of designing, designer should have an idea about the strength of concrete and modulus of elasticity of concrete. They has to consider all these things, and the material engineer has to be responsible for the concrete and properties specified by the designer will attain in the preparation of the concrete or not. So concrete states, there are two states of concrete, like first one is plastic state and next one is solid or hardened state. So the material engineer is concerned with the workability. Workability means ease to work, so it is the ability to work, and finishing characteristics of the concrete. Solid or hardened state, the material engineer is concerned with strength, modulus of elasticity, durability and porosity. Proportion of concrete mixes. The required qualities for concrete are, what are the qualities are expected in the concrete? Acceptable workability of freshly mixed concrete. So the freshly mixed concrete should have acceptable workability, and main thing, durability, strength, and uniform appearance of hardened concrete. The whole concrete should be appeared in a uniform appearance. So it can be gained when the mixing is done properly. Next one is economy. So we have to maintain economy every time without compromising the quality. So the main thing is mix design methods. So how to mix the concrete and what are the methods are there? So there are 3 methods, like random volume method, weight and absolute volume methods, and mixing concrete for small jobs. So random volume method, generally we'll consider 1:2:3 by volume, like cement 1, sand 2, coarse aggregate 3. So this explains you that 1 volume of cement is to 2 volume of sand fine aggregate and 3 volumes of coarse aggregate. This is how we pronounce the mix proportion. If I say 1:2:3, you must be able to understand that 1 volume of cement, 2 volume of sand, and 3 volume of coarse aggregate. Next, coming to weight and absolute volume methods. So what is this weight and absolute volume methods? To evaluate strength, water cement ratio, coarse aggregate, air entrainment, workability. So all this comes under weight and absolute volume methods. Another one, jobs requiring less than 1 cubic meter. Design effort is non-economical. So mixing concrete for small jobs. For small jobs, generally we can prefer hand mixing or machine mixing. So when the usage of concrete is less than 1 cubic meter. See, we have a mixing concrete for small jobs. This proportion of concrete mixes. If you observe this table, I have this first column, nominal maximum size of coarse aggregate. So coarse aggregate sizes in mm in inches, 9.5, 12.5, 19, 25 and 35. These are the sizes of aggregates. So this table gives you for air entrained concrete. So there are 2 types of concretes, air entrained concrete and non-air entrained concrete. So you can learn about these things in future. As of now, air entrained concrete means the concrete which is having some air voids, and non-air entrained means no air voids. So for this size of 9.5 mm aggregates, when you are using 9.5 mm aggregate, the cement we have to take is 0.210, the wet fine aggregate is 0.384, the wet coarse aggregate, and the water. So these are all the units. Like wet, what is the cement for 9.5? If it is non-air entrained concrete, the cement 0.2, the wet fine aggregate 0.407. From I have to take like this. So once you read this given conditions also. If coming to table 7.12, the relative components of concrete for small jobs. For the previous one, it is by weight. For now, it is by volume. So for the 9.5 size air entrained concrete, you have to take 0.190. For wet fine aggregates, you have to take 0.429. For wet coarse aggregate, you have to take 0.286. So this is just a tabular form. The combined volume is approximately 2/3 of the sum of the original bulk volumes. So as there is some bulking of the materials, we have to assume this. The combined volume is approximately 2/3 of the sum of the original bulk volumes. You remind this line and try to understand this line, which is helpful for us. In next video we are going to solve a very small problem, and I'll go through some important things related to concrete. So just remind this table 7.11 and table 7.12. 7.11 is by weight, 7.12 is by volume. Thank you.